creating, managing, and maintaining databases. All right, so at the heart of every single database platform is, of course, the database. It's where all the action is. It's where all of the tables, the data, objects, everything about our database is stored in the database. So that's what we're going to be covering in this video, everything there is to know about databases. We're going to start off here with a big introduction to databases. I'll get you familiar with the components of a database, both internally and externally. And what I mean by that is, of course, externally are the objects that we see that we're going to be manipulating and working with, creating and managing ourselves. And internally is, of course, the internal to SQL Server, the stuff we don't necessarily have control over, but it's good to know because it'll help us make smarter decisions when we're designing these databases. So we'll talk about all those components, see how they work and how they interact, and then we'll move in. I just briefly want to talk about how to design a database. I'll give you some good examples on what a basic database design looks like and what a more advanced database design would look like in situations for both of those. So once we get done with our introduction and getting familiar with databases, we'll move in to actually creating them. I'll show you how to create them using SQL Server Management Server, using the interface, and then I'll also show you how to create them using Transact SQL code. Good to know both because then there won't be a situation we can't handle when we need to create databases. We'll then move into managing databases, and here I'm going to get you familiar with your common everyday management tasks such as setting database options, expanding and shrinking your database, detaching, reattaching your database, taking it offline. So just again, common everyday management tasks. We'll then also move into maintaining databases, and here I'm going to get you familiar with how to create and automate a database maintenance plan. So just like our cars, we need to take our cars into the shop to get them, to get maintenance done on them, get them tuned up so they perform optimally. Same thing with our databases. We want our database to perform optimally, so we'll create a maintenance plan that kicks off every single night and just runs through all the different areas of our database, cleans it up, tidies it up, and tunes it up so it performs at its best. So let's kick things off here with an introduction to databases, and I'm going to get you familiar with all the different components inside of a database and how they work. Now, again, externally here to the outside world, once we create a database, we just see this database, right? And then we see all the objects underneath that database, such as the tables, the stored procedures, so on and so forth. But really what we're doing when we're creating a database is we're creating a collection of files. Because that's really all anything is anymore. And in Windows, it's just a collection of files with a fancy interface wrapped around it. Same thing with SQL Server, no different. When we create a database, we're really just creating a bunch of files. And then SQL Server manages, where those objects go in those files, where the data goes in those files, so on and so forth. So let's get familiar here with all the different objects. Starting at the top here, we have data files. Data files are the primary unit of storage in a SQL Server database. We have what's called our primary data files, and I should say data file because you can only ever have only one primary data file, and it's notified here with the MDF extension. So anytime you see an MDF extension, that is your primary data file for the database. What gets stored in the primary data file is all of the system objects. So all of the system tables, system stored procedures, anything that has the sys prefix on it is a system object, and that's what's stored in our primary data file. Also, the primary data file holds all kinds of pointer records to point to all the other files in our database if we do have other files, and the other files are called secondary files, and they're notified by an NDF extension. Now, secondary database files are completely optional. You do not need them at all. In which case, if you don't use secondary database files, then all of our user objects are going to get stored in our primary data file with our system objects. But we'll get into why we would want to use secondary database files in the next slide here when we talk about designing databases. But for now, know that we can have secondary database files. If we do have them, only user objects go into them. System objects always stay inside of the primary data file. And that's kind of what I'm trying to portray here with our bullet points. We also have the transaction log, and the transaction log is really used for recovery purposes, but basically how this works is any DML statement, any data manipulation statement that isn't a select statement, so all your action statements, your inserts, your updates, and your deletes, any of those actions that get ran against the database always get recorded in the transaction log before they get written to the data files. And the reason that is for, if something were to crash when a user ran a statement, things could go wrong inside of here. So we need a way to either roll back or roll forward any changes that were to happen in our database before that crash occurred. So transaction log is kind of our front line. It records everything that happens before it actually happens. We also have file groups, and file groups, we're going to get in and we're going to learn about how to use them and all that, but file groups are a way to to manage our data files. We can put multiple data files into a file group. There's always a primary file group, and that's where our primary data file goes, is always into the primary file group. So you can put other files into the primary file group with our primary data file, or we can create other secondary file groups and then put our data inside of those file groups as well. And don't worry if this sounds confusing, it's really not, because, and I'll show you in our next slide when we talk about designing them, why we use file groups, what the benefits are, and how we do so. And we'll also get in, we'll actually create file groups when we create databases and learn how to do these types of things. Now, one more thing about file groups. When we create our objects, in other words, let's say we create a table. We can't specifically say we want to create this table on a specific data file. Instead, what we can do is we can say we want to create this table on a specific file group. So that's where file groups will come in handy, and we'll talk about that when we get there. Now, everything I mentioned up to this point, data files, transaction logs, file groups, these are all objects that are external. In other words, we have control over them. We can manipulate them. We can change settings and create them in the sense of data files and file groups, and even transaction logs. These other two items down here, data pages and extents, these are internal storage mechanisms to SQL Server, so we don't have any control on how they work. I just want to get you familiar with them, because in the land of SQL Server, I'm sure you'll come across these terms, and it's good to know how SQL Server does business underneath the hood. Here's how it works. Data pages are pretty much the smallest unit of storage when it comes to storing data and objects in SQL Server, right? Inside of these data files, we have a bunch of data pages, and a data page is 8 kilobytes in size, which means that you'll have up to 128 data pages per megabyte, right? And that's all. Data pages store everything from the table definitions to the actual data row itself to store procedures, triggers, you name it. It's all stored in a data page, every object you can think of in a database. We also have something called an extent. And an extent is actually 8 data pages. And what an extent really is it's just the basic unit of storage management inside of SQL Server. So it's how it manages all of our data pages at the extent level. Now, because extents are made up of pages, of course, this means that each extent is 64 kilobytes in size, and we can have 16 extents per megabyte. Now, there's two types of extents out there. We have mixed extents, and we have uniform extents. How this works is a mixed extent, let's say, for instance, we created a very small table, right? Had a couple of columns in it, no data in it yet, so it wouldn't consume very much space inside of our data page here, maybe very, very little. Well, instead of SQL Server allocating an entire extent for just our single table, what it'll do is it'll look around and say, all right, what kind of extents, give me a mixed extent out there that has other small objects scattered about these data pages. What it'll do is it'll put that small table inside of a mixed extent. Now, as time goes on, we add some columns to this table. There's a lot of data in this table. What'll happen is this table will take up more and more pages. Well, once this table reaches 8 pages and it can fill up the entire extent, SQL Server will flip it to what's called a uniform extent. So all that basically means is a uniform extent is owned by one single object, and a mixed extent is owned by many objects. And what does all this mean? Well, not really much to us. Again, this is all just internal storage mechanisms to SQL Server. It's just good to know. So these are all the major components that make up a database. Let's put them all into perspective a little better by taking a look at how we would design a database. And I'm going to show you two different database structures here. First, the basic database structure, and then we'll move on to an advanced database structure. And what I did here is let's say you have a fresh installation of SQL Server out there. You go right in after you install SQL Server and you create a new database. Well, this is exactly how that database will look on paper. It's very basic, very simple. And I just want to mention here that when you do create databases, they're based on the model database. So if you've seen the model system database, anything you do in that database will be reflected in all new databases that you take. It's pretty much just a template for the new database. So that's what this is. This is exactly what a brand new database would look like in a fresh installation. We have one primary file group, so that's what the square is notified here is the file group. We have one primary data file, which is of course our MDF file, and we have one transaction log here. Again, transaction logs have the LDF extensions. And that's it. As simple as that. Anytime we created an object of our own, it would get stored inside of our primary data file within our primary file group. So that's as simple as it gets there. Now, this isn't necessarily a bad design. It's a very simplistic design, which is low on the management level. So it doesn't take a lot to manage it. You're not going to get optimal performance by any means, but easy to manage, simple design, great for small and medium-sized databases. The advanced database structure, though, is handy if you need the performance increase, if you have a lot of activity and you want to speed up performance. Again, a little harder to manage just because we have more files and file groups to manage, but at the same time, again, it could be worth the performance gain. And basically how this would work, let's say we created this database structure. We would create one primary file group with the primary data file in it. That would actually get created automatically for us. And let's say we have some sales tables out there that have a lot of activity on them. We'd like to put them in their own file group on their own separate disks, so we speed things up here, and I'll explain how this works. But what we would do is we'd go ahead and we'd create a secondary file group. We'd create a couple of data files. We'd put these data files inside of this file group. Now, how this would work, and this is kind of cool, what we could do is we could take each one of these data files and put them on their own separate physical disk, right? And as I mentioned before, if we were to create a table, we create the table at the file group level, not the file level. So let's say we took all of our sales tables and we moved them, we put them into this secondary file group here. SQL Server will go ahead and split those tables amongst these data pages across the physical disks here. And now anytime a query came in to our sales tables, the query would come into our secondary file group here. SQL Server would say, oh, that table is split across multiple tables. What I'll do is I will run this query asynchronously across both of those disks to find the data I need, and then, of course, return the results to the user in about half the time it would take over here on one disk. So pretty cool stuff here. That's a very nice advantage to doing things like this. You could also accomplish the same exact thing by creating this file group on one disk that is, of course, a RAID stripe set. So RAID being the redundant array of independent disks, you can accomplish the same thing doing that. But if you don't have that option, then just pop these data files on separate physical disks, and boom, we're off and running. Now our queries are running twice as fast. You can also do the same thing with transaction logs. You can have more than one transaction log, and you can also put these on separate physical disks to make logging a lot faster as well. So you can see there's benefits, pros and cons to both of these, like everything else in life and in the database world. Pros and cons to both. Do you want less management, easier to manage, a little bit slower on the data side, or do you want a little bit more management, but a lot more performance? That's up to you. All right, let's jump into SQL Server Management Studio here and learn how to create databases. Now, we're going to create our database based on this advanced structure here, so we can get a feel of how file groups work and how we can put data files into file groups, so on and so forth. The basic database structure, you already know how to create this. If you have a default installation of SQL Server 2005 laying around, just create a database. Very simple to do. The only thing you'll have to supply it is a name, and that's it. Really no setup after that. It's as simple as that, and that's how the default installations are set up. So to get into SQL Server Management Studio here, let's head on down to the Start menu, up to Programs, over to SQL Server 2005, and right down to SQL Server Management Studio. As soon as this fires up, we'll connect to our development instance over there on our SQL Nugget machine. That way we can do all of our developing over here, and then I'll show you how we can roll this out to production using attaching and detaching. And what we're going to do first here is create a database through the interface. Then I'll show you the scripting way to do it. I have a transact SQL statement that'll do exactly what we're going to do using the interface here. So to create a new database, we just simply right-click on the databases node and choose New Database. This will bring up the New Database dialog box. The first thing we need to do is define our database name. So let's call this the CBT Nuggets database. There we are. The next thing it's going to have us do is if we want to choose an owner other than ourselves, we can here. Default is just going to pick up you, the individual who's creating the database. We can also enable this database for full text searching, which utilizes full text indexing to do that, something we'll cover in a future video. So you can enable that right off the bat here. You can also enable it at a later date. You're not locked into it here when you create the database. And the next thing we do here is define our database files. So here are all the files that are associated with our database here. And you can see by default, it's very simple, just one primary data file and one log file. And again, log files are not tied to any file group. And just to go through some of these columns here, we have our logical name. And the logical name is the name that we can refer to this in Transact SQL code. In other areas of SQL Server may ask for the name of the file, and this is how you would supply it using the logical name. Some other columns in here, again, the file group that this file is associated with. You can see I can't change this file group here, and I'll show you that we can when we add more files because, of course, it's the primary data file. You have an initial size. You can change that. We have some auto growth options here. If you click on the build button, you can see auto growth is enabled by default, and this just means once the database size gets to a certain level here, it grows beyond the point that we allocated for it here, past the initial size, what do we want to do? Do you want to automatically grow it in megabytes and a percentage? And you can also put a maximum file size on here. And then if you, of course, if you uncheck enable auto growth, then once it hits this site, it'll just stop, and you won't be able to insert any more data into it. Your users will get errors, so on and so forth. So it's good to enable auto growth. Disk space is cheap these days, and of course, we're probably going to have these databases on a pretty large server, especially in a production environment. So that's how you can enable auto growth. Also here we have the actual physical path, not the file name, but the path to where these data files are going to store, and then the file name. And the file name is actually going to take the logical name and then put a .mdf on the end of it and a .ldf on the end of it once we go ahead and click OK here to create our database. But before we do that here, we're going to add some more files. So to add another file, let's click the Add button. And the first thing we can do here is give it, of course, our logical name. Now what we're going to do is we're going to have 2 primary files and 3 secondary files. We're going to have 2 primary files in the primary file group, and then we'll create another file group to put those other files in. And why would we want to do this? Well, a good reason to have 2 primary files in the primary file group is to keep our system objects performing optimally. We could put these 2 separate files on 2 separate physical disks, but they'll still be participating in this file group with all the system objects being thrown into these files. So one way to keep your primary file group at optimal performance. So what we're going to do here is name this one CBT Nuggets primary 2, and then we'll come back up to this guy here and call this primary 1. So now we have 2 primary data files inside of the primary file group, and you can see here if I drop down this primary file, you can see we can choose, this will list all of our file groups, and we can also choose to create a new one here, which we'll do shortly. But that looks good here for our secondary file inside of our primary file group. Looks pretty good. Let's add a few more here. How about this one we call CBT Nuggets underscore sales 1. And we're going to make a sales file group, and we'll have 3 sales files that we'll add into this file group. So what I'm going to do here is drop down the file group and choose new file group. And what this is going to do is a very simple dialog group here. Let's just give this simply a name. So we'll name this the sales file group. And then we can make this a read-only file group, in which case we would say only read-only objects would go in this file group. So maybe historical data, for instance. So this would be a great way to really speed up performance. And there's other things you can do with read-only file groups, but you'd only put history tables on this read-only file group. A good way to do that. You can also make this file group the default, meaning any new objects created in SQL Server will automatically get assigned to this file group. We're going to leave that alone though for now. And we'll just create a file group called sales and click OK. Boom. Now we have a sales file group. Doesn't get any easier than that. Let's add a few more in here. We'll call this guy sales 2, and I'm just going to copy this, paste it in, and change it to 2. We'll assign this to the secondary file group as well. And then one more here, sales 3. And there we go. And we'll also assign this guy to the sales file group. And there we go. Now we have all of our data files set up, and we even have our file groups set up in here. And if you didn't want to manage your file groups doing the way I did here, just choosing new file groups, there's actually a file groups tab over here that allows us, as you can see, to do just that. Basically, we can reset our defaults here. We can make our file groups read-only. And obviously, you can't make the primary file group read-only. And then it also just shows us what files are in here. And you can also click Add here, and this will allow you to do the same thing that dialog box did. And I'm just going to hit Remove here, remove that empty file group. And then other things we have here are the Options tab, which we'll get into here shortly. But basically, this is all we need to do to create our database. Now, if we click OK, it's going to go ahead and execute, run through, create our data files, assign them to the appropriate file groups, and when all set, it should create our database. And there we are. There is our CBT Nuggets database. Now let's take a look at what we did in creating our database here. And to get to the properties of a database, just simply right-click on it and head on down to the Properties menu item here. As soon as you click on that, we'll have our Properties dialog that opens up. The General tab here just has general information about our database, who created it, the status, the time it was created, the size, space available, things of that nature. If we head down to the Files node here, this should look familiar to you. All of our data files, check it out. The only difference is now if we scroll over to the right, we actually have file names because they've been physically created since we created the database here. You can see it just takes the logical name and then adds the appropriate extension on here. We only have one primary data file, which is our MDF extension. And then we have a secondary data file that we added to the primary file group. So this will work, this will cooperate with our primary data file to store system objects. And then check it out, we have our 3 secondary files all in our secondary file group here. And again, you're not really locked into anything. You can add more data files in here. You can remove data files. The only thing you're locked into is the file group. Once you have created the data file itself here and clicked OK, then we can't change the file group that it's assigned to. But you can, however, edit actual file groups. So if you head down to the file groups node here, you can add more file groups, create new files, add those files into their respective file groups, so on and so forth. So pretty cool that you can edit all this stuff on the fly. Also here we have the options node, and this will allow you to change just general options relating to the database. Here you have your collation level, recovery model, which we touch on in our backup and restore video. We also have compatibility level that this database is running in. And then you have all kinds of other standard options, all your automatic options, close, create statistics, shrink, update statistics. We'll touch on some of these when we get into indexing, and we'll talk about shrinking here shortly. Also, if you want to know what any one of these specifically does, you have this little help button up here. This is really handy. It'll go through and tell us what each one of these does in detail. So you have some other things. A lot of these are relating to transact SQL statements and how transact SQL and certain things about transact SQL acts within this database and any sessions that connect to this database. At the bottom here you have some useful ones. You have the state of your database. You can set the database to read-only here. And also you can restrict access. By default, multi-user means everyone's allowed in. Single user means only one user at a time. And restricted user means only the sysadmin will be allowed inside of this database. So that could come in handy at some point. And then other things here, simply you have permissions on the database. And then other things that we've talked about in previous videos, mirroring, transaction log shipping, and extended properties are just name value pairs that you want to add in here to describe certain things about the database. So that's pretty much everything you need to know in a nutshell about creating your databases. Now, one thing I want to show you here is how we can do this using transact SQL code. So I'm going to open up a file that I created here by going to File, Open, File, and then I created a little script called Creating Databases here, and I'm going to connect right into our dev instance once again. And what I did here is I created a script that does both. It creates a simple database, just kind of the default database, and then also the one that we just created, same exact one here. So I'm going to go ahead and delete our CBC Nuggets database. I could have also did that by running a little code snippet that I put together up here. If dbid CBC Nuggets is not null, then drop database CBC Nuggets. And this dbid function is nice, just takes the name of a database, and if it's not null, then that means it exists. So in that case, we would drop the database. Same thing as if I just right-clicked and choose delete it. So creating a simple database, very simple here. You just simply do a create database followed by the database name, and then on primary means this is going on the primary file group here. And this is, of course, going to be our CBC Nuggets underscore data file. So this is the logical name here, not the actual physical name. And the physical name is we use the file name option here. File name equals and the path to the actual file name. We're just going to call this cbcnuggets.mdf. And then you do a log on, and then pretty much the same parameters here, just a name and a file name. And there are more parameters. This is in its simplest form. How it looks, and it's going to take up all the defaults for everything else, such as the size. The initial size will be 2 megabytes, things like that, all the defaults that were accepted in the interface. And then again here, our log, our name, CBC Nuggets underscore log, name of the file, same thing, CBC Nuggets underscore log.ldf. So if we highlight all this and choose execute, it's going to run through and create our database for us. There we go. If we right click and refresh our database node, there's our CBC Nuggets database. And I'm just going to fly through the properties here just to show you. On our files, here they are, CBC Nuggets underscore data. Here is the actual path, file name, and then our log file as well. Pretty simple. We didn't add any file groups in there, so we just have the primary data file, and that's it. Simple as that for creating a standard database here. Then we'll go ahead and drop this database by highlighting this code and choose execute. Now if we refresh, there we go. No more database. Let's take that to the next level here. If I scroll down to our database with file groups, pretty much the same thing. We just do a create database followed by the name of the database, and then we're going to say on primary here for these files. And again, 2 primary data files. Here's our primary 1, here's our primary 2. We specify our logical name and our physical name. Pri1, pri2.mdf.mdf. And you can see here I actually, you don't have to name them the same. That's just the default. As you can see, I named it logically underscore primary 2, but the actual data file is pri2. So just to show you that you can do that. The next thing we do is create our next 3 files here, and all we need to do is just say file group sales. This will automatically create the sales file group for us, and then throw these 3 files into that files group with the name sales1, sales2, sales3, and their corresponding data files named the same. And then just one log file, once again, works the same. So you can see, using the minimal parameters, it's very simple to create databases in code. We highlight all this, hit execute, refresh our databases over here. Oh, not quite done yet. Jumping the gun here. It's got a lot to create. Now if we hit refresh, there it is, our CBT Nuggets database. And just to show you here, if I fly through the properties, you can see on our Files tab, there they all are. See, it automatically created the sales file group for us. And you can see the defaults here on our actual initial sizes, 1 megabyte for anything that isn't the primary data file. So that's how that works. And that's all there is to it. So creating database is very simple, doing it through the interface, and also very simple, doing it through code. Now, another thing we're going to move into here is attaching and detaching databases. And this really gives us an option, another way of moving and copying databases around, a much easier way than the whole backup and restore process. But really what this does physically is it detaches the data files from the database. And what that allows us to do then, doing that detach process, unlocks the actual files themselves on the hard drive, so we may copy or move them around. Very simple to do this. We right click on the database. We want to, in our case, what we're going to do here, we're going to copy the CBT Nuggets database here from our dev server to our production server. We'll say we're ready to roll it out. Much easier doing it this way. So what we'll do here is we'll first detach it from our development database. So that'll free up again the locks on the files so we may move them. A couple of things you can do here. You can drop all your connections. This will actually physically drop the connections and forcibly drop the connections in this database. Because you actually can't detach a database if it has connections to it. So that's why this is here. You may, of course, not want to do this and notify any users, just ask them to get out of the application or out of the database before you actually do that. But so we'll leave that just like that. You can also do an update statistics here. This will just pretty much update all the information and the metadata regarding your indexes. Really, the statistics is all around query optimization. Just it makes the query optimizer enables the query optimizer to make smarter decisions when it's running queries against your database. So you may want to do this. It'll update all the old statistics and metadata about those indexes. And also you can keep your full text indexes intact here. This will actually keep the full text files themselves associated with the database. We'll leave the defaults here and choose OK. And what that'll do is it'll detach again the database from the files. And look at that, you're not even going to see the database. It's going to take you right out of here. Didn't delete it, just detached it. Now the next step here, we need to take those data files and copy them over into the right area so we may use them in our production database. And to do that here, I'm going to just using UNC name here, I'm going to fly over to our SQL Nugget machine. Here it is, into our SQL Server database. And what I'm going to do here is I'm going to take, again, those data files from our dev instance and copy them into our production instance folder. And to do this here, let's just go ahead and take a look at the AdventureWorks database. Hit the properties. We'll go to files here, and just to see where these data files are stored, you can see they're stored in the MSSQL.4 MSSQL data folder. So that's where they should be stored. If we go into 4 here, MSSQL data, check it out here, all the data files, and look at it, look familiar? We have our primary, our 2 primaries, and our 3 secondaries, and also our log file here. If we take all of these, right click, and choose copy, there we are, and now we head up into our production instance, which I know is SQL.1 here, into data, and let's copy, or actually paste, all of those data files over here. Here it goes, copy primary 1, primary 2, all of our secondary files. Now they're over here. Now what we can do is head on over to our production instance. We'll go ahead and connect to it here via Object Explorer. There we are. Head on into databases. If we right click on databases, look at this. We have an attach menu item here. If we choose the attach menu item and click on add, it's going to open up our dialog to allow us to browse through the folders and choose a file that we want to add. And the cool thing about this, you're going to notice there's only MDF files shown in here. Why is that? Where are other files? Well, if we click on this and choose OK, watch what will happen here. Again, primary data file is the pointer to all of the other data files, and really the main file inside of our database. So it knows where all those other files are. We don't have to worry about selecting every single file, and that's why it also says up here MDF file location. So we have all the files here. Everything looks good. You can even change the paths here if you'd like to with the build button. We'll accept all the defaults and choose OK. And what it's going to do, is to attach our database. Check it out. We just moved, or actually copied, our database over to here. And now, if we want to take our database, our development database, and get it back online, we can do the same thing. Right-click on database, choose attach, choose add here. And again, same exact thing. It's just going to fire open this folder dialog box, show us, now we're in the .4, we're in this instances folder rather than the .1, which is our production instance. Same thing here, we'll choose our primary data file, click OK. It's going to go ahead, run through, find all those secondary files, toss them on in here. There we go. We click OK, and we're back online. Now we have two databases, one in our development, one in our production. So you can see attaching, detaching, very simple to do, very, very useful, and that's how you do it. Now, a few more management tasks I'd like to show you here is how to expand and shrink your database. And actually, expanding we already went through, but let me go through it again. There's a few other things you can do. If you right-click on your database and go to Properties, and head into our Files node here, we can see we can actually just up it by typing right in here. Say we wanted to expand our database, our primary data file, by 2 megs. Well, there you go. Up it to 4. Same with our secondary one. We'll up this to 2. You can see just by doing this, it's actually, as soon as we click OK, it's going to automatically allocate this space to these data files as soon as we click OK. So, and then the other option is, of course, auto-growing. Another way to expand it, this will automatically enable, if you enable auto-growth, once your database fills up, it'll automatically do it. The next time data is put into it, it'll expand it by this megabytes or by that percentage, so on and so forth. But again, if you're not going to use auto-growth, then you can just simply up the initial size here, and that'll automatically allocate space on the fly. So as soon as we do this here, click OK, boom, our database is now allocating that space, and now those data files have some extra space to work with. Pretty simple. Shrinking everything, on the other hand, is a little bit different. If we want to shrink our data files or even our entire database, we can do that by right-clicking on our database, going over to Tasks here, and right up to Shrink. And you can do either or. You can shrink the database or you can shrink specific files. Both of these actually run a dbcc command, the Database Consistency Checker command. You can do a dbcc space shrink database, that's what this uses, or a dbcc shrink file. And the dbcc shrink file, of course, takes a file name or a file path that you'd like to shrink, and that's it. We're off and running here. And I'm going to show you how to shrink the database here, the entire database. And if you click on this menu item, we'll fire up here the shrink database dialog. Very simple to do, not a lot we can do here. It's just going to tell us that it's going to attempt to shrink all of our database files and release that unused space back to the operating system. And if you want to shrink individual files, use shrink files instead. So that's all these are. An interface around the dbcc command. And just to show you here how that looks, dbcc shrink database, and that's it. You can actually run this all by itself, or you can pass in a target percentage. And if we put that percentage in here, that just simply means it'll attempt to shrink the database and leave 10% of free space inside of our data files. But let's do this through the interface here. And that's all it's going to tell us. It's going to show us the currently allocated space here, 14 megs. And this went up since obviously we changed and expanded our database. And then it just shows us our available free space amongst all of our data files is 77%. So if we choose this, it'll reorganize the files before releasing that unused space. And then we can say we want to leave about 10% left in there. And it should shrink this down to 10%. So we have 10% of free space in here. If we click OK, it's going to run that dbcc command underneath the hood, shrink our database. Now if we go into the properties and take a look, check it out. It definitely shrunk it. We're not at 14 megs anymore. We're now at 6.49 megs, about 10% of available space as opposed to what we had before. So that's it. Pretty simple to shrink your database. Simple to shrink files too. You can go right into shrink files. And again, pretty much the same interface here. We just choose what, your file type, choose what file group, choose your actual file, and then the same thing, currently allocated space, available free space. Only you have a few more options. You can choose to release the unused space back to the operating system. Again, reorganize it, leaving megabytes rather than percentage here. And then you can actually empty the file completely and migrate data to other file groups, other files inside of this file group. So a few more options here with shrinking file, but nonetheless, same result. You're just shrinking and releasing unused space back to the operating system. All right, so that's how we can pretty much manage our database by shrinking, expanding, attaching, detaching, all pretty simple stuff. Now, another really cool thing we can do here is create what's called the maintenance plan. And maintenance plans have been around before. It's just that now we have more control than ever when creating these maintenance plans. Let me show you an example here. Let's head on down to our production database here. And if you go into the management node and expand it, you're going to see a maintenance plan folder. And we're just going to right click on this and choose New Maintenance Plan. First thing it's going to ask us is a name. And why don't we call this our CBT Nuggets underscore plan. How about we call this our daily plan, because we're going to run this, schedule it to run every single night. So we'll give it a name here, you click OK, and then what it's going to do is it's going to fire open a little designer here that'll allow us to kind of design our maintenance plan. And really what this is it's a streamlined version of SSIS, SQL Server Integration Services. I'm just going to go ahead and hide our registered servers here in our Object Explorer here to get a little more screen space to work with. But very simple to use, and get the hang of how this works, because SQL Server Integration Services, formerly named DTS, Data Transformation Services, very, very, very powerful, especially when it comes to automating everyday tasks and even uncommon tasks. You can automate some pretty serious stuff here using SSIS. But we'll stick with maintenance plans here. Very simple to do. We can give it a description here. You can put it on a schedule. We'll talk about that here shortly. But let's say, for instance, we just want to run a nightly maintenance plan to clean up our database, kind of verify that our database is in a good running state and just keep it at optimal performance. So to create our package over here, we have some tasks. Each one of these is a task, and what we're basically going to do is we're going to throw these tasks onto the designer, and we can have multiple tasks we can throw onto the designer, and then we can link them together using what are called precedence constraints, and I'll explain those here in it shortly. But very simple to do, and this is really cool. If you hold your mouse over any one of these tasks, it'll tell us what that task does. So the check database integrity task, for instance, checks the integrity task, performs internal consistency checks of the data and index pages within our database. So that's a good one to do. We'll do that one. Some other ones here, reorganizing your indexes is excellent. It'll go ahead and defragment all of the indexes so our queries are performing optimally. The queries that use these indexes are, of course, performing optimally. Check it out. We have a shrink database task. It'll do exactly what we just did, only it'll do it automated. Update statistics, again, to make sure that our query optimizer makes good decisions about what indexes to use and such. So again, to use these, very simple. We just drag them onto the designer here. So how about the first one we do here? Let's go ahead and reorganize all of our indexes. So we'll just drag this right on here. Now, if you see a task in the designer has a little red X, it means it needs more information from us. So if we double click on the task, we'll give it that information. First thing it needs is a connection. You can choose the local server connection that we're currently logged in as, or you can define a new connection here, give it all the credentials it needs. We'll leave that at the default. Next thing we need to do is define a database here. So we're going to say the CBT Nuggets database, of course. Next thing you can do, you can choose all tables and views, or you can choose a specific table, in which case it'll have you choose a specific table out of there. We're just going to go ahead and say reorganize the index on the indexes on all of our tables and views. So we choose OK, boom, we're all set. And again, what this will do is this will actually reorganize all of the actual indexes in our data pages, so they're again tighter on the data pages, they'll perform better, so on and so forth. So they're not fragmented essentially. Other things we'll do here, how about we go ahead and update statistics. Let's throw this guy on here too. We'll update the statistics so our query optimizer can make better decisions on what indexes to use when the queries come into our databases. So we'll double click on this, do the same thing here. We'll leave it at our local server connection. We'll choose our CBT Nuggets database. How about all tables and views, update the statistics on, and all the statistics, not just column statistics, but indexes as well. And choose OK. There we go. So we have a couple of tasks on here. How about we get another one going here? How about our shrink database? So we'll get a shrink database. We'll toss this guy on here. Double click on it, give it some information. And we'll use the local server connection here. We'll choose our CBT Nuggets database. A couple of options here you can choose. It won't run this task if it is below this actual megabyte percentage here, or megabyte size. So we'll say, how about if it gets above 20 megs? Then go ahead and shrink it. And you can choose, again, the amount of free space and what you want to do with that free space. Release it to the operating system or leave it in the database files. We'll say release it to the operating system here and choose OK. So we got 3 tasks on here now. And how about we kind of structure these so they run in the order we want them to run. So let's say we want the reorganize index task to run first. Well, what we can do here is when you click on a task, you'll see this little arrow drops down. If you grab the arrow and drag it, you can see we created what's called a precedence constraint, meaning that this is going to run before this runs. And we can do the same thing with this green one here. We can drag this green one and say we want to shrink the database next. There we go. So now reorganize index, then update statistics, then shrink our database. I'm just going to give us a little more space to work with here. Here we go. And you can see you can actually tighten these up and move them around at will. They have size handles on them here, so I'm just going to do that because we're going to drag a few more tasks onto our maintenance plan. And the task that we're going to drag on here next is our consistency check. So we'll check the database consistency at the very end to make sure everything is good. And if you double click on this, we can say, yep, we want to make sure that our CBT Nuggets database is consistent and also the indexes on them are consistent. So we'll click OK, and we'll say we want this to happen after the database is shrunk. So the very last step here is our check database integrity. And one more thing that we're going to do, and this is really cool, you'll notice that there's a notify operator task. Let's drag this on here at the very end here, and let's go ahead and double click on it. We're going to say, yep, we want to notify our SQL admin if anything goes wrong, and we'll give it a message. We'll say that our integrity check failed! Exclamation point, exclamation point, exclamation point. Say OK. Now what we're going to do is instead of we're going to drag this guy down here, but we're going to change this green arrow, this green precedence constraint, to red. And you do that by right-clicking on it and saying failure. So what that means is if this fails, notify our operator. And you can actually drag an operator task on here for every one of these if you wanted to. And you can see each precedent constraint, you can say that. You can say execute this task if this succeeds currently, or you can say execute it if it fails, or execute it on completion, which is a blue arrow. But of course, we want these all to execute in succession of one another, and at the very end here, we want this notify operator task only to kick off if our integrity check fails. And actually, you don't have to create a notify operator task for each one of these. You can actually just drag another arrow down here and choose failure. There you go. So you can actually drag all these down here, so if any one of these tasks fail, notify our operator. But we're just going to leave that at the check database integrity test for now. So once you're all set here, you can do a few other things. Again, you can schedule this, which if you click on the build button, will just bring up the scheduler. We'll say, sure, we want this to run, how about every night at, call it 3 a.m. in the morning, starting now, and boom, there you go. Now it's on a recurring schedule. Every morning it'll run. You can delete the schedule, change it if you'd like. You can also have some logging options here. You can have it generate a text file. You can have it append to the text file after every run. You can send the report to an email, which is, of course, our operator here, so on and so forth. So a lot of cool things you can do within the package. Once you're all set, you just simply choose Save. And now guess what? As soon as it's done saving, we can close out of it. And let's get back into our Object Explorer here. If we refresh our maintenance plans, guess what? We have a maintenance plan in here. No problem. You can edit this at any time, modify it. You can view the history. This will give us an entire history. Check it out using our little log viewer of all the runs, what the plan was, the task, the duration, the log type, and of course if it succeeded or failed or not. So just a simple maintenance plan. And you can actually right-click and choose Execute as well, and it'll run through all those steps. So I just right-clicked, choose Execute. May take a bit because it has quite a bit to do in here, but you know what? Our database is empty. We haven't really done anything in it, so it shouldn't take that long to do. But pretty cool. You can create as many maintenance plans as you want. No limit to that, but they are stored at the server level, not the database level. So keep in mind, you may want to name them accordingly so you know what database they fit in. And there we go. Finished up there, successful. And there we go. Our maintenance plan is done. All right, so in this CBT Nugget, we took a big look at creating, managing, and maintaining databases. We started off here with an introduction to databases. I got you familiar with all the different components that make up a database, the physical components that make up a database, such as the data files, the file groups. We also took a look at what's inside of a data file, data pages, data rows, extents, things of that nature. We then took a look at how to design databases. I showed you a simple design, kind of the default design that comes with the fresh installation of SQL Server when you create databases, and also a more complex design that took data files and allows us to associate those data files with specific file groups and also log files, and took a look at both of those scenarios and how they work. We then moved into actually creating databases. We created a database, we created some data files, we added those data files into specific file groups, showed you how to do that both in the interface and using Transact SQL code. And then we moved into managing databases, got you familiar with some common tasks such as attaching, detaching databases, shrinking, expanding databases, and data files. And at the end here, we took a big look at how to maintain a database by creating a database maintenance plan, which uses a very slick interface, the new SQL Server Integration Services interface, to create a task-based GUI-oriented system where we just drag these tasks onto a designer, set some properties, create precedence constraints between all of these tasks, and boom, create a schedule, and we're off and running with a maintenance plan. So I hope this has been informative for you, and I thank you for viewing.